Hyperledger Iroha, and we're the main maintainer of it right now. And we use Iroha for a few different applications, and I'll talk about some of the applications today, just as examples. And but yeah, just to give you a brief overview, we've used Iroha for retail payment system in the Kingdom of Cambodia called Bakong. So I'll talk about that as an example. But we've also done lots of other work. So for example, we worked with Moscow Exchange Group and KDD, which is the Slovenian Central Securities Depository, on a project called D3 Ledger, which is it's a kind of interledger platform where you can move assets from Hyperledger Iroha to, well, between Hyperledger Iroha and Ethereum, and also the Bitcoin blockchain. So you can move Bitcoins onto Iroha and then move them back to the Bitcoin blockchain as well. And that's an open source project called D3 Ledger, which uses Hyperledger Iroha as the main blockchain. And then we've used Hyperledger Iroha for a project called Sora, which is a decentralized world economic system. And I'll talk a little bit about that today and some of the interesting work that we're doing with that. We've also focused on not just payments, but with identity as well. So we've worked with Bank Central Asia in Indonesia on a prototype identity system using the W3C standards of decentralized identifiers and verifiable claims. And actually, in the Hyperledger Iroha blockchain, this is quite an easy thing to do because we have a key value map associated with every account that you can store information about. So I can talk about that as well. Besides Iroha, we've done quite a lot of other work. We work now with Web3 Foundation on building C++ version of Polkadot, which is the inter-blockchain protocol. And we also work with Protocol Labs on Filecoin. We built the C++ client for Filecoin as well. So we've done a lot of different work. Here, I'll just turn my video off. Just before I talk a little bit about Iroha and some of the features, I would like to present Project Bakong as an example of something you can do, and then use that as a way to explain Iroha and to go into some more details. So Project Bakong is a central bank real-time retail payment system, something similar to what's called a central bank digital currency. So lots of central banks have been talking about launching digital currencies. You know, everyone knows about China's project, of course, and Sweden has been talking for years about the e-krona project. Even Turkey has been talking about projects. Ukraine did a pilot last year. Even India has been talking about sovereign digital currency as well. So lots of people are talking and studying this in detail. But one of the first applications really is Bakong, which is in Cambodia. And this is the world's first retail payment system run by a central bank using blockchain technology. And it currently has more than 10,000 retail users, and more than 14 financial institutions are partnered with it. And you know, there's a fair amount of use since it started last July. In Bakong, anyone with a Cambodian phone number can download the mobile app and make payments to like a Cambodian phone number, really. And this is using the Hyperledger Iroha blockchain. And as was mentioned in the introduction, Hyperledger Iroha focuses a lot on creating software development kits for things like mobile applications, web applications, to make it as easy as possible for people to do things like key generation and be able to sign transactions. So I'll talk a little bit about some of this in my talk today. But I think the easiest thing is to just kind of show a demo of the application. So Bakong is a retail payments app, first and foremost. There's of course other applications that are involved, like backend systems for banks to use and things like that. But from a retail standpoint, it's just a mobile wallet. So as you can see, I have two currencies. I have a Khmer Real and the US dollar. And I've got some balances here. This is real money, so I'm not going to send too much, but I'll try to send some to a friend. So you have 4 buttons down below. You have send, receive, QR pay, and deposit. And if you hit send, you can type in a phone number in Cambodia if you know one, or you can and let me copy my my friend's ID just to make it easy. So paste the ID, and this is a way to search for a username in the system, and then you can send, for example, 1 cent. You can send some message like "Hi there," and then this hasn't sent the transaction yet. This is confirmation screen, and you can see the recipient, the amount, the phone number, and different things. So I hit confirm, and then what it does is it signs the transaction locally on my phone, and then it sends it to the backend system, which actually finalizes it as a blockchain transaction. And as you can see, it's already done. So it takes about maybe 2 to 3 seconds to finalize the transaction in the system. So it's very fast, and it's just a way to kind of like send money between different retail customers. You can also send and receive using a QR code, similar to different things like Alipay. Or, I'm not sure what they have in India. Maybe something like UPI supports payments like this. But you can put in an invoice, and people can send scan the QR code to send you some money. And if you have an existing bank account at one of the partner institutions, you can type in the bank account number, and then it will send money to the Bakong system. So, and then of course there's the QR pay feature. So now that I showed you the basic app overviews, the demo, and you have maybe an idea of what you can do using Hyperledger Iroha technology, let's talk a little bit about how this was built, and maybe how you can do similar types of things yourself. So when you register in a Bakong system, there's a list of the 14 different banks that are partners, and you can choose one of the banks to be your bank. So this is a little bit different from traditional banking systems where you go to a bank and you have to open an account and it takes lots of time. This is a special digital currency account where you go to one of the banks and you choose one of the banks when you're registering in the app, and then after just doing a simple phone number verification, you're able to be onboarded and send and receive money, albeit with limits. So to prevent, to comply with regulations, when you first register with just your phone number verification, there's a very strict limit that you can do per day. But then if you go to one of the banks and do KYC in person, you're able to get a higher limit. And also as part of the onboarding process, we built some tools to make it easier to verify identity. So you can, for example, scan passport, and then it does face recognition between the face on the passport and your face, and it does liveness detection as well. In fact, we also published a paper about this digital identity protocol called Sora Identity, Secure Digital Identity on the Blockchain. And this is an example, and this paper explains in detail the protocol for doing decentralized identifiers and verifiable claims on top of Iroha. But getting back to the Bakong system, in addition to mobile apps, there's also desktop apps that banks use, and the tellers have their own accounts and private keys to be able to do things like sign transactions. The system architecture is designed so that it's a 2-tier system with Hyperledger Iroha as the core system that processes all the account balances and manages creating funds and transferring funds. money is created, or these types of, the money is created in the Bakong system by one of the commercial banks sends a transaction to a technical account that, I don't mean a blockchain transaction, but like a real real transaction in the national payment system. They send money to a technical account that then will tokenize the money that has been sent to it, and then give the tokens to the bank, and then the bank can give these tokens to its users or its customers, right? So for example, if you are a customer, you can go to a bank in person and you can give them maybe $50 in cash, and you can get $50 worth of tokens sent to your QR code. And then you can transact digitally. So the banks are the intermediaries in the system, and the central bank runs the ledger that has all the ground truth, but the commercial banks maintain direct access to the customers. And they do this by running a payment gateway that the mobile apps connect to, and other apps in the system connect to the payment gateway. And also commercial bank's core banking system connects to the gateway, and it processes transactions and manages account balances. The integration with the core banking system is done via ISO 20022 messaging. So this is fine and good, but another key point about this architecture is that when a user has a mobile phone, a mobile application that is being connected to the system, the user generates their own keys. So every user, when they install the app generates keys, and then it registers the public key with the payment gateway when they register. So no one else has the private key, only the user has private keys. And this is important, and I'll explain how Iroha helps it later, but if a user loses their phone, then you need to get support about how to recover your keys. And Iroha is a great permissioning system that I'll talk about later that allows the bank to remove an old key and add a new key to the system without touching the account's balance. So that's, I think, one of the key features of our system. But yeah, just to maybe finish up with Bakong. Bakong has been mentioned in many different articles. Even the World Economic Forum mentioned it in their report this year. And the pilot launched last year in July, and there's about 600 stores accepting the Bakong payment throughout the country right now. You might ask, why would blockchain be used by a system like this? Because the central bank runs all the core servers anyway. Why not just use a database like Oracle? Well, the answer is that you can simplify the payments architecture by having kind of all the banks join at a level playing field. So the central bank runs the core ledger that has the ground truth, but every commercial bank joins the system via a gateway, and then they're able to provide services to their end clients like through this gateway. And so it's a way to create a really highly scalable system, but also with that flat hierarchies, because all the commercial banks are at the same level. Another key point, I would say, is the decentralization of the business logic, even though that the infrastructure is actually somewhat centralized, because the central bank, of course, runs all the system, all the core system. What I mean is that each end user generates their own keys, and so no one else can fake a transaction or steal users' money, because these assets, the money, is associated with the user's account on the ledger. And so it kind of gives a way to create a trust minimized system that also has mathematically provable ownership of some money or some property. So this is a very good, I would say, feature. In Cambodia, there's a large unbanked population, of course, which is one of the main motivations for this system. According to the World Bank report, only 22% of people over the age of 15 have bank accounts. So it's a very large portion of the population doesn't have proper access to financial services. There's also a large remittance market, meaning that people go off to work and then they send money back home. But unlike in many countries, this is a domestic remittance market. So people send this money domestically. So there's quite a lot of value for the central bank doing this even inside the country, because people are going from the countryside, they're going to the capital and working and then sending money back home to their family. And then there's also very few digital payments going on in the country, which is a little bit surprising because so many people have cell phones right now. So something like 80% of people have smartphones, and more than 120% have mobile phones in the country, because people have more than one phone usually. So it's actually, yeah, people don't really have access to financial services, but they all have access to smartphones and to cell phones in general. And so it makes a lot of sense to have a digital payment system like this. So so Bakong kind of improves financial inclusiveness, and then also makes it cheaper and faster to send money digitally, either to your family or to make digital payments for things like e-commerce, for instance. And there's some effects on monetary policy, but I think this is mainly a developer-oriented talk. So let's get into some details about Hyperledger Iroha now that you've seen some of the examples of what we can do. So Hyperledger Iroha, well, just to tell the story in a brief way, we started working on this in 2016, and one of our main motivations was to create a blockchain that made it really easy to create assets and transfer assets. So an asset is something like money, like a payment, or it can be some kind of a finite object, like a digitization of a painting or a piece of land or a car. Being able to easily create these assets and transfer them to other people without having to write a lot of code, and then also by having kind of a mobile first architecture and orientation is something that we wanted to focus on. So we kind of focused, instead of allowing people to write Turing complete smart contracts using some kind of scripting language, instead what we decided to do was to create a data model that is very simple, and create different commands that allow you to interact with the data model. So the data model is very simple. It's shown here on the slide. You have domains. A domain is like a namespace or a container that you have, and inside of the domain you have assets and you have accounts. And an asset is just a name and a quantity. So an asset can really be used to represent anything, and it's up to the human user to give it meaning. So if you have an asset named like 1994 Toyota Tercel or something, so this would be a car, and the user would know it's a car because they're familiar with the domain knowledge. And so that's one example, but it can also be, US dollar or rupiah or different things, right? And then accounts have the assets. So accounts are the actors that do some kind of action in the system. So like creating an asset or transferring an asset. And accounts, to increase the security, they have different signatures, and the signatures are what I mean is a cryptographic signature. So there's signatories that are on an account, and in practice, these are public keys. So you can have multiple public keys associated with an account, and you can set a quorum of the public keys, and you can use this as a threshold to execute transactions. And you can also give permissions associated with an account. Here's some examples of some of the commands. that we have in Hyperledger Iroha. So we have different asset commands. So if you want to create an asset, you just call the command create asset. If you want to transfer an asset, you can transfer the asset. And you can do the same type of thing with accounts, and you can also add and remove signatories with accounts and set quorum and different things like that. So let's take a little bit of a look at how this is done. So we have on this website Coda this example, and it won't take 10 minutes, so don't worry. I'm going to get the Docker image launched as I explained. So this is an example that you can walk through that can give you an idea of how to use at least the Python library that we have. But we try to make it so that the different libraries that work with Iroha are kind of more or less the same type of interface, the same types of patterns. So in this example, we have a Docker image that's loaded, and it has two accounts. There's Alice at test and Bob at test. And here, I'll zoom in. So test is in our, going back to the slides, is our domain. So the name of our domain is test. Alice and Bob are names of accounts. So this is how we namespace things. Asset names in Iroha look like this. You have an asset named coin, and the domain is test. So coin, like number sign and test means the coin that's in the test domain. Okay, so I loaded up a Docker image, so I'm going to hit next. In this example, we have a couple of files in Python. One is the client py, and the other is add asset, which I'll show in a second. The client Python uses our library Iroha. So Iroha is our Python library. Because, like I said, all the commands that you execute in Iroha are executed by an account. When you set up the library, you put the account that you're using. So, like for example, Alice at test is the account that we're using right now for this library. In production, obviously, you don't want to put your private key in your code, but as an example, here's just the private key. And then Iroha gRPC uses, of course, like the name suggests, gRPC as the messaging or connection networking service. So what client.py does is very simple. It initializes the library with Alice at test, sets Alice, send it to the network using net.send transaction, and then it will get the status from the network. So let's go to the next step. So the next step is to, as an example, we're going to add an asset quantity, and I'm gonna. So add asset quantity is, going back to the slides, is one of the commands that we have. So you have create asset, but in this example, coin, the asset named coin already exists, so we're going to add more coins. It's basically like minting money. So let's give it a cool value like 777 as the amount. So so what this does, so this is really easy, right? The command add asset quantity, you tell it the asset ID and the amount that you want to add. So this is how you mint money in this system. But you have to have permission, of course, but Alice has permission. So let's hit continue, and then I'll click on this, and it will execute this file add asset quantity, which what it does is it actually creates the transaction and then sends it to to the Iroha server that's running in this Docker image, and then it does the various steps. So let's go through it a little bit. So when you create the transaction, you send it and you get the transaction hash. You use the transaction hash to keep track of the status of the transaction because you want to know what happened with the transaction. Like, was it committed in a block, for instance, things like that. So when you send the transaction to an Iroha server, it does what's called stateless validation, and it checks to make sure that the transaction has valid signatures and that the format is correct. So when it says enough signatures collected, that means that it was able to get that the signatures were correct and that it was the proper amount of signatures on a transaction, because you can have multi-signature transactions, right? And then after this stateless validation, it does stateful validation, and then after that it says stateful validation is a success, which is good. That means that permissions are okay and everything is fine. And then finally it says committed. So that just means that it was actually created and put into a block and committed directly. And we can execute this command here, and we can see this queries the data from the local block storage and allows us to look directly at the data. And you can see here that we have our coins inside the add asset quantity and associated with the account Alice at test, which is great. That's exactly what we want. So we go to next. So next, now that we have some coins, we can transfer some to from Alice to Bob. So let's open transfer assets and then copy this code. So again, this is, I think, pretty straightforward. We tried to make it really easy to use Iroha, and what we have is we have a transfer asset command. And transfer asset means that you transfer an asset from a source account, which is Alice, to a destination account, which is Bob. And you tell it the asset ID, which is coin in the domain test. And let's be nice to Bob and send maybe 3. Okay, and now we can execute this. So let's click this and then scroll down. So you can see that it got not enough signatures, it was correct, and then it does stateful validation, it was correct, and then it says committed. So that means that Alice was able to send 3 test coins to Bob. Now let's check the assets that Bob has. Instead of querying from the block storage, which is kind of messy, we can actually use the query API. So let's create this get account assets file and then copy this over. So again, we try to make it pretty easy. We have a get account assets query, which is a command that we execute on Bob at test, which will just get all the assets that Bob has and print them out. So let's try this. So there, it says coin test balance 3. So we were able to send 3 coins to Bob, and Bob was able to receive these 3 coins. Cool. So that's an example of what these slides mean, really, in that we're trying to create really easy tools that allow you to interact with the blockchain. So the blockchain itself doesn't have to be a hard or complicated thing. It can just be a package that you can work with. And we put a lot of effort into designing the system and making it kind of easy and composable. So let's go into a little bit more details, and then I can give a few examples, and then finally I can I'll probably end by talking a little bit about our plans for version 2 and how to get involved. Okay, so one other key part of that you might have thought about during my example in the Python library is if you can just add asset quantity, then everyone can mint money, right? But that means it doesn't have any value. So in Iroha, what we do is we have a permission that is associated with each of the commands. So if you have permission to execute some command, you can execute it, but other people can't. And this permission also works with queries. So you can limit who can see what data. It doesn't have to be. This is kind of a confusing figure, but there's lots of can permissions. So like, can you add a peer? Can you add a signatory? Can you get all the accounts? Can you get my account? Different things like that. And earlier I was talking about the Bakong system and how if you lose your phone, your bank can change your signatories. So you can see there's this command down in the lower right called can grant add signatory. So this gives the ability of an account the ability to grant the add signatory permission to another account. So for example, Alice can give this permission to add a signatory to her account to Bob, and then Bob can add new signatories, meaning new keys, to Alice's account if he wants. And that's one way that you can do account recovery, because if you lose your phone, then your bank can add your new key after you register again in the app. This is obviously a very sensitive thing, and so you have to be careful, and you have to check someone's ID, and you can't do this electronically. You have to do it in person because of security issues, I think. Cool. So that is some examples, and I just talked about the user protection. There's a few other things that we've done with Iroha version 1. We built this app called Moika, which is what we built for a project at the in Aizu Wakamatsu in Fukushima Prefecture. And what this is a local currency that was done just at an event that was created by people interacting with each other. So actually what happened was one person would walk up to someone else, and they would shake their phone, and then a QR code would be displayed, but for like maybe 5 seconds or so. And then another user has to scan the QR code before the QR code disappears. And then scanning the QR code has data that are used to mint new tokens, and they're giving the new tokens to the two users. So this is like a currency that's created through social interaction. The idea is that interacting with people has some kind of value, and by creating some kind of token and giving it to people, it's a way to kind of quantify this value in a way. And at the event, people were able to use these tokens to buy coffee, to buy popcorn, different things like that. So it's kind of like a silly and fun thing, but actually it's quite some serious research, and we worked on this with University of Tokyo and University of Aizu, and also International University of Japan, Bakong, on this research project. So this is one example of how you can easily use the commands in Iroha to do kind of interesting applications, like, for example, minting a new currency. We also expanded this to this platform called Bakong, which is it's a campus currency at the University of Aizu. And we built a prototype 2 years ago, and then finally next month we're releasing a live version of this, like a final version. I can show you the app now, so just one moment. Quick time. Cool. So this is the app. This is just a kind of like a prepaid type of app. So you go to the university and you give them some Japanese yen in cash, and then they give you these Japanese yen tokens, and you can send and receive using QR code, of course. And you can, also if you know someone's address, you can type it in. I've got Vadim registered here, so I'm going to send him some yen. I'll send him 2 yen and maybe hello message. Then hit send, and then it's processing. This system is using using the Sora network. So Sora is like a digital currency type of system. Oh, see, it's done already now, and it has processed. Yeah, that's kind of you can see the app. And so this is just a way to easily buy things on campus and be able to kind of send money either between students or to buy food on campus or buy other types of things. So this is geared towards university students. And actually, we built this as a nice package. So if anyone is interested in expanding this to any universities in India, let me know. We're happy to work on it. There's some other things I want to mention. Since I have some time, I'm going to talk a little bit about some of our ideas for improving Iroha and making it even better in version 2.0 that we're working on. So the key entry point to everything Iroha is the wiki page. So there's this URL at wiki.hyperledger.org/display/Iroha. It's not a very friendly URL, but this is the kind of the key entry point to everything going on with Iroha. So there's different documentation. There's the link to different repositories. Like for example, the Python SDK that I just showed you is here, and this is where you can get the code and get some more documentation. There's a link to the mailing list. There's a Telegram group and Gitter and other chat, Rocket Chat links. These are all linked together using a bridge, so you can post questions on any of these chats and different things like that. So inside of the wiki, we have an Iroha 2 section, and Iroha 2 section has a lot of things. One thing that's really interesting maybe is the request for comments that talks a lot about some of the new development work that we're doing on Iroha 2. So for example, the DSL structure and things like that. So in the Iroha 1 commands, we decided to just limit the amount of the potential for people to make mistakes. And as you can see in the example that I gave, you can only execute a few different commands. It's a very limiting set. But for some applications, you want to have more flexibility. And so we're actually trying to make the DSLs, make a more robust DSL that is, from a mathematical point, Turing complete. And we call this not commands, but the ISI, or the Iroha special instructions. And these have this, but the idea is the same, really. If you want to register an account or register an asset, you register the account or the asset. If you want to add an asset quantity, you add the quantity to the asset. So it's a way to kind of like mix and match different commands. And then the Turing completeness comes from event handling, where you can implement any new recursive function using events that are kind of like conditional listeners that will listen for some event and then output new transactions that then in turn can trigger other events on the blockchain. So that's one of the changes. Another big change potentially is that we're working on Iroha version 2 in Rust instead of in C++. Iroha version 1 is in C++. Rust is, I don't know how big the community is in India, but it's a language that is increasing in users every year. And it's really quite an interesting language. The compiler is very strict, and that's a good thing. You want problems to be found at compile time, not at runtime. And many types of or classes of problems that are possible in C++ are not possible to have in Rust. And the Rust compiler is also very friendly, and people like the compiler because it helps you out a lot more than in C++. The code right now for so all the Iroha code, by the way, is at GitHub /Hyperledger/Iroha. And if you go to the branches, we've got Iroha 2 dev and then different things, Iroha 2. But Iroha 2 dev is the current dev branch for Iroha 2, and it has a lot of the some of the details about getting set up. We have some Docker images, so you can use Docker Compose, and it's pretty simple to set up. And I'll talk a little bit more about some of the features in a few minutes. Great. So yeah. So I talked a little bit about the Iroha special instructions. One other thing that might be interesting is that we are focusing kind of on, well, the main, you can do any type of domain with the Iroha special instructions, but we're focusing mainly on asset management, identity, and DeFi, or decentralized finance applications. So there's this Iroha substrate module or crate here, and what this is a work in progress, but this is a bridge when it's done. This is going to be a bridge for Polkadot ecosystem and substrate clients, or blockchains or parachains to connect to. So what you can do is you can have Iroha interfacing with other blockchains that use Web3 substrate, which is part of the Polkadot project that is being built. So that's one of the ideas, is to make it really easy to do different applications, like build a bridge to another blockchain to move. So that way you can mint assets on Iroha, and you can move it to other blockchains more easily, and do the opposite too. We also have a somewhat new and improved consensus algorithm in Iroha version 2 called Sumeragi. And this is a Byzantine fault-tolerant algorithm that is heavily inspired by the B-chain algorithm, which is from Professor Duan in this paper here, B-chain, and you can find it online. But I can spend a few minutes talking just about the basic idea of the algorithm, because I think it's somewhat interesting. So in Sumeragi, you have a known set of validators. Let's say there's 4 different nodes in your network, and most voting-based Byzantine fault-tolerant consensus algorithms don't really consider like an ordering over the nodes. Like all the nodes are kind of like equal. Maybe you have a leader, maybe you don't. In B-chain and in Sumeragi, there's a topology that's overlaid on the network, and this is an ordering of the nodes. And like what you do is you take to prevent things like censorship and bad actors, you reorder the nodes. It's like a conceptual ordering. You reorder this on every block. So you have a function that takes as input the previous block hash, and this acts kind of like a seed to a random number generator. You can then reorder your network so that you have, instead of like 1, 2, 3, 4, you have node 3 is in the beginning, and then 1, 2, and 4. And then in this case, this node number 3 would be the leader in this consensus round. And then in Byzantine fault-tolerant consensus, like in B-chain, you have 3f plus 1 nodes, where f is the number of Byzantine faults that you want to tolerate. With a network of 4 nodes, you can tolerate 1 Byzantine fault, so 3f plus, or 3 plus 1 is 4. And then to actually finalize the blocks, you do supermajority consensus or voting. So you need 2f plus 1, or in this case 3 nodes to vote. So you have a leader, and you have a proxy tail, which is the 2f plus first node. And then the last node is kind of not participating in the main consensus. And you divide this into like set A and set B, where you have set A would be the first 2f plus 1 nodes, and then set B would be the length f nodes, or cardinality of f set. So let's say you have some transactions, and then so what the leader does is they create a block proposal. The leader then submits this block proposal to all the peers in set A. So this would be nodes 1 and 2 in this case. And then node 2, which is the proxy tail, collects all the signatures. So node 2 is trying to get 2f plus 1 signatures, or 3 signatures. So they get their 3 signatures, and then after that they transmit to all the blocks a commit message. And this will, the nodes will then commit the block when receiving this message, like that. And then the next round can begin, where you get the new block hash and you reorder the nodes, and the process continues. Now, there's a few things to keep in your mind. One of them is that this is the sunny day case where there's no problems. If there's some kind of problem, then what you have to do is you have to bring in nodes in set B that will then receive the block and then have to participate in voting in order to expand the signatures so that you can get enough signatures. And that if you don't get enough signatures even after doing that, then that could mean that the leader and the proxy tail are collaborating to be bad. And so what you have to do is you have to rearrange the node order, and then the consensus will restart with a new leader and a new proxy tail. And of course, the white paper has all these details, but the key point is that normal consensus flow is highly optimized, and that's what you want, because in permissioned networks like Iroha, it's not like Bitcoin, where anyone can join the network and potentially mine. Though of course in Bitcoin it's very hard to. You have to be a millionaire to be able to mine a block yourself. But the key point is that most nodes will not be malicious because it's closed network for most of the time. So for the normal case, it makes sense to optimize. There's another thing that those who are familiar with consensus algorithms might have realized. There's no two-phase commit when you commit the block. Instead, what we do is, because we optimize this for payments, and the block time is only maybe 1 to 2 seconds between blocks, instead of doing a two-phase commit, you build the next block on top of the current block, and then this will finalize the block when the next block is built. So to really get transaction finality, you have to wait until the next block comes, is one of the trade-offs. But like I said, if you're trying to work with just a payment application, you can wait maybe a couple of seconds longer to get that assurance if you need to. It's not a huge problem. So this is also kind of a new and improved algorithm that we have in Iroha version 2. Iroha version 2 is kind of structured so that you have the core Iroha libraries, and then you have like the clients, and then there's a CLI for clients, but that's kind of just like something to play around with for now. And then you have like the networking as a separate crate, and then we also try to keep things like the macros separate as well. So there's different. I think the structure is pretty easy to see and to play around with. It's still very rough, and it's under constant work. So if you want to play around with something unstable, you can check out Iroha 2, or if you want to do something stable in production, you can go to our releases and you can use Iroha v2 1.2, which is the C++ version, which is using which is much more tested and highly reliable. There's going to be a 1.2 final release soon for Iroha 1 that has some performance increases, and then we also have done tighter security review, so it's improved, I would say. We also use Hyperledger Iroha now for all cryptography, which is a great library as well. But this is kind of like a collection of different cryptographic utils. So if you need to support some strange cryptographic algorithm, there's a good chance that Iroha probably has it. Let's see. We're using Hyperledger Iroha 2 actually in the creation of Sora, which is a decentralized economic system. And so we have a simple network now, but in Sora, it basically works like a decentralized autonomous organization. We call it decentralized autonomous economy. And people vote on how you mint new tokens. And this voting is done on the blockchain. So I can show you the app actually. Let's switch over to QuickTime and then go here. Okay, great. So we have different projects here, and these are projects that people can vote for, and this is a way to allocate new tokens. So there's this token called XOR, and then it's minted by people getting votes, and then there's no projects that are actively voting today, so I can't show you the voting, but there's just a simple way where you can take some of your votes. Like I've got 13,000 votes here in the corner. You can take these votes and you can vote for different projects. And then each vote is turned into new tokens. And so it's kind of like a way to democratize the creation of new tokens in the economy. That's why we call it a decentralized autonomous economy. And because the key part of this system, this is like a cryptocurrency, the key part of the system is actually the token and not the technology. We actually try to make the token exist on many different networks. So there's already a bridge to Ethereum, but coming with Hyperledger Iroha version 2, we're also building a bridge to Kusama, which is the one of the Polkadot networks, and the Polkadot relay chain, and then to Bitcoin as well. So this is kind of like a way to bring assets from these different networks onto the Sora network version 2 that uses Hyperledger Iroha version 2. And on top of this, will also be like a DEX and like different applications and decentralized apps that people can create using the Iroha special instructions and then put them on the blockchain, and then be able to do different asset management and commands associated with them. So that's this is kind of an exciting thing that we're working on, and we're making a lot of progress every day. So I would encourage you to get involved if you have any interest either in C++ version or Rust version of Iroha. Please let us know. Just because we're working on version 2 doesn't mean that version 1 is going away. It's still going to be around, and we're going to support it for a while. And version 2 is also a very exciting piece of research, so I encourage people to get involved. Cool. So with that, I think we can take some questions. Okay, so one question is Iroha mainly being developed in Japan? Iroha is an international project, so it's not mainly Japanese anymore. When we started, it was mostly just a bunch of our team in Japan, and we also co-submitted the proposal with NTT Data and Hitachi, who are also Hyperledger members. But nowadays we have a pretty international team. There's a lot of people in Europe, a lot of people in Russia. So people in lots of time zones. I don't know. I think maybe there's some people in the community who are from India as well. But I've never actually made it to India myself, and so I think this is a great opportunity to get more people involved. Okay, so can we say Iroha is for cryptocurrency fabrics for smart contracts? I wouldn't say that. I would say that Iroha is good for, well, you have to think about what are the use cases that blockchain is for. And blockchain, the main use case, I would say, is the creation of digitally scarce items. And these items could be a currency, it could be a cryptocurrency, it could be a point system, but it can also be things like identity. It can also be things like rights to some kind of title. And what Iroha lets you do is be able to send different be able to manipulate these different types of items in an easy way. Fabric doesn't really make any assumptions about what you're trying to work with, and it gives you a key value map where you can write a lot of code that will modify different values. You can also do a lot of this in Iroha as well, but I think we focus mainly on, instead of making it so that the main use case is to do anything, we kind of focus mainly on just like asset and identity management. So it's kind of by limiting the use cases that you focus on, you're also able to make it easier to work with, which I think we're able to accomplish. Another person asks, can you give some insights on the database part? Where are the transactions stored? Okay, this is a great, very interesting questions. And there's two answers, one for version 1, one for version 2. In Iroha version 1, we used PostgreSQL as a SQL database to store what's called world state. And this is the account balances. This is the information about the assets and the signatories, different things like that. And then we have a data storage on disk that is a block, just a block store, and I think it's using JSON by default as a storage format, but I think that might be configurable. In Iroha version 2, we decided, hey, it's 2020. Computers are a lot more powerful now. Like even my computer I'm using now has 64 gigabytes of RAM. And so let's just get rid of all this on-disk storage and use in-memory only. So in Hyperledger Iroha version 2, we have a block storage that is a permanent storage. So when you finalize a block and commit it, you commit it at the same time, and atomically you commit it to the local storage, but you also extract all the data that you need to support queries and put it into key value maps that are in memory. So basically hash maps. When you start up the system at the beginning, you read through all the blocks in order and you fill out the current state in the hash maps. And because you're doing this in this way, it's extremely fast. Like it's pretty unbelievable. But the downside is you need lots of memory. But actually, that's not a huge problem anymore because lots of people have lots of memory now. Okay, so another person asks about Iroha use for IoT applications. So Iroha is written in C++, so there's a lot of potential hardware that can support it. And we try to use libraries that are easily supportable by a lot of the hardware. Iroha version 2, we're using Rust, but Rust still has pretty good hardware support, and some core parts are using the no standard library, so you can use it possibly for embedded things. Yeah, someone asked for some more videos on YouTube. Yeah, I think that's a great thing that we could do. I think maybe before that we can work more on building tutorials like I went through earlier in Python, maybe for other languages. But yeah, this is something that, yeah, I agree, we need more. We could use more videos explaining tutorials about how to use it. So Iroha, yeah, it does work quite a lot on, we focus a lot on mobile apps and SDKs. So if you go to our wiki page, there's repositories, and then there's different repositories, like, for example, Iroha iOS. So this is a SDK for Iroha that's for Swift. So you can install this and then use CocoaPods, if you're familiar with that, to install this. And then what this does is it allows you to do the same types of things that I showed in the Python library, where you can create different transactions and get transaction statuses and things like that. There's an example, I guess, here too. Oh, yeah, I'm not going to try to look at that in right now, but that's for the iOS version. And then for Android, we also have an Android SDK as well that does the same type of thing. So you can use this to easily generate different types of transactions and send them using gRPC to Iroha. So Iroha version 1 uses gRPC for the API, which is a bit cumbersome, but if you have a SDK in your language, and we support iOS, Android, JavaScript, and Python, then it's not so hard, actually. Let's see, what else do we have here? Are there any plans to add bridge between different blockchains in version 1? Okay, so we have, don't know if this website will work. So there's a project we worked on which is called D3 Ledger, and D3 Ledger has like this D3 ETH and kind of a notary system. And so this is for Iroha version 1, where you run a federated set of notaries on top of Iroha, and and you have to deploy a special smart contract on Ethereum. And then what you can do is you can send ERC20 tokens to the smart contract, and then the smart contract will be read by the notaries, and then the notaries will create the asset on Iroha. And you can do the opposite too. You can take your Iroha asset and you can send it to a special address on Iroha. Then the notaries will automatically contact smart contract that you deployed on Ethereum, and then be able to mint and demint tokens correctly so that you can move tokens from one blockchain to another. So this is already implemented for Iroha 1. But it's a little bit cumbersome, so you have to do this on top of Iroha. And so for version 2, we're trying to build this more into the core, so it's a lot easier. But it's dealing with multiple blockchains is always very difficult because a lot of things can go wrong. So another question: are there any communities using Iroha? There's quite a lot of people in our chat group. So if you go back to the wiki, you can click on like one of the chat, like for example Telegram, and then I'm not going to open that right now, but yeah, there's a few hundred, like 400 people or so in that chat, and then there's people on Rocket Chat as well and on Gitter. So you can join the community, and we are thinking about trying to have like some more hackathons in the future here. So I think that'll be a way to kind of expand the community as well. Let's see, another question is, do you see increasing enthusiasm among different communities to adopt blockchain, especially by government-backed authorities? Yeah, this is a great question. Well, just 2 days ago, the National Bank of Cambodia released a white paper about Bakong. And so this was a really interesting paper that talks about a lot of their thoughts on blockchain and using blockchain. So I recommend trying to read this if you're interested. Also, I would say that, yeah, a lot of different governments are looking at blockchain. There's, for example, European Commission has some research projects on it. A lot of central banks have been looking at blockchain, especially for payments. And there's a lot of people looking at different ideas. I don't know much about the current state in India, but I imagine that there's quite a lot of work being done because there's quite a lot of highly talented developer communities and lots of work being done, I think, with Fabric and similar technologies there. Can we do a pilot project in Kerala similar to the one in Iroha that we did in the University of Aizu? Yeah, that would be awesome. So that's that would be really quite a cool thing to do. Let's see. So Byakko is the pilot here, so, or the command. So what we can do is, if we had like a university or some company, then this is really just a way to tokenize fiat money. So like legally, you can't just create a currency, right? It's not, it's a very hard thing to do. But in most countries, it's okay if you have the same company that is the issuer and also the receiver of the money. And that's what a university is for a university payment system, right? So the university issues the currency to the students, and then the university is the only one that accepts it. So there's no financial or money laundering risk because of that structure. So if we did that in Kerala, we could have like some company that maybe, I don't know, some university maybe that would be the issuer, and then you could use the currency at the university cafeteria or store or things like that. That would be very interesting to try. So yeah, out of everything we presented today, most of it is, well, a lot of it is public. So for example, on GitHub, we have Sora Zor, which is, Sora is, has the iOS and Android applications on here. And then, of course, Iroha and all the libraries are Apache 2 license and open source, so people are free to play with that. D3 is also public, and people can use that. So yeah, we try to do a lot of things open source. Let's see, can Iroha be used with enterprise asset management software such as IBM Maximo or SAP? Yeah, I don't see any reason why not. This hasn't really been a demand that we've had, so we haven't really integrated it. And also, you should think about what the role should be. Like, should it be for payments? Should it be for just keeping track of balances of different types of goods, like in a logistics system? Yeah, but if you can model something as assets, then it should be possible to use Iroha for it, because Iroha is a really simple ledger. It just has this notion of an asset and an account that has the asset, and so anything can be an asset.
Hi, Franklin here.
Hello.
That was a wonderful session. As part of the Hyperledger group or community here, so one of the major questions that you might have already answered when we were discussing about Fabric and Iroha, but we would like to know about how Iroha actually stands apart from other Hyperledger projects, mainly from Sawtooth or other projects, apart from the assets. Why should we actually consider Iroha for our project development, or is there a USP in that case? That's one of the main questions. You might be already hearing this, but for just for the clarity, how is it different actually?
Yeah, sure. This is yeah. There's as you may know, there's many different projects in the Hyperledger greenhouse. Hyperledger Iroha is just one of the 6 projects that are in Hyperledger, well, 6 core platforms, and different platforms kind of have different goals. So Fabric mainly focuses on things like just having key value maps and being able to represent different logic by moving these different maps around to change a world state. Iroha tries to make this more explicit and has the data model that then you can manipulate balances in the data model. And then in Sawtooth Lake, there's different. Sawtooth Lake is kind of interesting because it has the flexibility of different things like transaction families that make it easy to model a lot of assets in a way that's I think very logical and similar in some ways to Iroha. And then of course there's 2 Ethereum style platforms, which are Ursa and Burl, and they focus mainly on Solidity style smart contracts. And the last one is Indy, which is tries to focus on identity as the main use case. So each platform kind of has its own different philosophy, and we try to be a collaborative community, so we don't, it's not all about competition, though at the end of the day, users should choose, what works best for their application. So it really depends a lot on what you're trying to do. I think if you're trying to do some kind of features that are already built into Iroha as one of the core commands, then it's pretty easy to just work with that. But Iroha tries to make it easy to do things, but at the expense of flexibility. So it's not as flexible as Fabric for some things. So if you try to do some kind of non-standard application, that could be hard to do. That being said, in version 2, we're trying to improve that and give people more options. But still, we're trying to make it so that most use cases can be done just with the core system without having to do a lot of things. I don't really want to say, Fabric or Iroha are better per se. It really depends a lot on what your motivations are and what the use cases are trying to do. For things, for things like creating assets and moving assets around, maybe even doing things like verifiable claims by setting the account detail on well, it's a key value map associated with accounts. So there's pretty easy ways to manage identity in Iroha, and I think if you're trying to just do something like that, it's pretty easy to use Iroha. If you're trying to do something like really have like a key value state that you're trying to update and get consensus about, maybe with some very complex logic, then Fabric is easier to work with in that respect in many ways. But I mean, it really, I mean, I'm not, I don't really want to say, you know, any global rules about which to use. Obviously, we we like Iroha, otherwise we wouldn't be working on it. But yeah, there's always any system has trade-offs, and so there's there's good things and bad things about any of these blockchain systems, depending on the perspective of the use case. Is there a peer order or identity management seen in Fabric? So in Iroha, well, peers have an identity that's associated with a public key, and you have to have permission to join the network by, there's an add peer command that has to be signed off on by 2/3 of the network in order to join. Any other questions? Is Hyperledger Aries compatible with Iroha? I don't think it's compatible yet. We've been trying to collaborate more with some of the other systems. So we use Hyperledger Ursa now in both Iroha 1 and 2. And we just integrated Hyperledger Burl in version 1.2 of Iroha. So you can actually execute some Solidity contracts if you wanted to in Iroha version 1.2. So yeah, I mean, there's other platforms that we try to work with. So someone just asked a question about performance tests. So we also we had integrated before with Hyperledger Caliper, but you know, projects change over time, and Caliper changed some things and it broke the integration, and then I don't know if it's been fixed yet. But yeah, there's quite a lot of things going on. There's also you know, Quill. Well, I don't know if Quill's still around or not. There's a few other projects out there that would be great to have integrated. We support. We built an integration with Hyperledger Explorer, but honestly, it's kind of not a very good integration. So how many transactions per second? So this depends on the number of nodes and kind of capabilities of the network. But typically, if you have between 4 and maybe 22 nodes in the network, it's pretty fast. If you have good network and connectivity, you can get probably a few thousand transactions per second. In Iroha 2, it'll be even faster, mainly because we're making everything in memory, and it's generally pretty easy to get pretty good performance in Iroha because we limit the types of commands that are executed to the commands in Iroha v1, and then the Iroha special instructions in v2. Is it possible to develop a messenger using Iroha? If possible, what will it ask to be transferred? Okay, this is interesting. So as you might have noticed in my demos of the apps, I included a message. So let's see if I can find it easily. Apologies. Okay. So I'll try to find this real quick. Maybe I'll just give up. Okay, so anyway, to answer the question quickly, there's some kind of description field that you can put associated with a transaction, and yeah, the message where I wrote hello. So you can actually include a message or any kind of blob of bytes along with the transaction. So one way to easily develop a messenger would just be to create a transfer transaction between two accounts. And I don't know if it's valid to have a quantity of 0. If so, you could just create like an asset and then like transfer quantity 0 to another account and use the message. Or you could just have a really small value, depending on, I don't know what the validation rule is for that. So that would be one way to do it. It's interesting. I hadn't really thought about making messenger system, but could be fun.